ID, the Future, a podcast about evolution and intelligent design.
How would you explain intelligent design to someone who's just recently begun looking into it? Hello, I'm Tom Gilson. Today we hear Casey Luskin, Associate Director of the Discovery Institute's Center for Science and Culture, doing just that, explaining it to Sam Kleckley, who's interviewing him on his Live Life in Motion podcast. In this first of two parts, Casey gives a nice overview of where and when the idea of intelligent design began, how it's developed, and why it has become such a compelling idea to so many.
Casey, man, what's up? Good to meet you. First off, how you doing? How's your day going?
It's been a bit of a crazy day. I was on vacation last week. This is my first day back in the office after vacation. So you know how that goes. It's like, oh my gosh, it takes a lot of work to go on vacation, and vacations are great, but you pay for it on either end. So I'm paying for it right now.
That's so true. I don't know where you went on vacation, but is it one of those vacations where you just overeat and kind of overindulge the whole time?
Hardly, actually. I was visiting family down in Southern California, but my cousin and I and his son went camping on Catalina Island, and it was pretty primitive. We actually had no water, no bathrooms, no electricity, and also no shade for about 3 days. It was super fun, but definitely we were not eating gourmet. I had cans of chili and packets of rice. We had a great time. Did a lot of fishing, snorkeling, and kayaking. Just had an epic time. It was really cool. Yeah.
Very, very cool. That's a little different. I just went on family vacation. Of course, all we did was eat. So I was like trying to figure out my eating habits when I get back in Greenville.
I've done those too.
Yeah, right. Sometimes you get the best of both worlds. I'm excited to have you on. I was telling you before we press record that recently this has been a big topic in my mind, in my brain. I've been trying to figure out what intelligent design is and the evidence behind it. And just once you dive into it, you realize there's this huge community out there for both kind of sides of, is it human evolution? Is it intelligent design? Where do they collide? And doing research, I found you at Discovery Institute, and I got linked up with you, and I'm very excited to have you on. Can you tell people more of your background, and then we'll kind of get into what intelligent design is?
Sure. So I work at Discovery Institute, which is we call ourselves the leading institutional home or a think tank for the theory of intelligent design. And we can get into what the theory of intelligent design is, but we are a think tank. We're nonpartisan, nonprofit, public policy think tank. We deal with many issues from transportation to communication to foreign affairs, economics, urban planning, education, bioethics, leadership. But I think we're most well known for our work in the area of origins and how did life begin? What is the origin of the universe? Are we the result of strictly unguided material evolutionary processes, or is there some design behind life and the universe? So my academic background is I got my undergraduate and master's degree in earth sciences from the University of California, San Diego. And while I was there, I actually took a lot of courses in evolution at the undergraduate and graduate levels. So I sort of have a pretty solid background in evolutionary biology. And then I went to law school, actually. I decided to get a job. I should maybe go to law school. So I went to law school and I became a California licensed attorney. I've been a California licensed attorney since 2005. And then at the very end of 2015, early 2016, I went back to school. I thought I was done with school. I'd sworn off school, but somehow it got me. And I went back and got a PhD in geology at the University of Johannesburg. So my wife and I moved to Johannesburg in South Africa for about a little under 4.5 years. And had an amazing experience doing that. I got a PhD in geology there. And again, had many opportunities also while I was there to learn about the topic of human evolution. My research was on Archean geology. So my PhD topic was not on human evolution, but I was able to visit many of the famous hominid fossil sites and hominid fossil museums, interact with some leading paleoanthropologists, people at some of the top, human origins research institutes in the world. Had a lot of great opportunities to learn about the topic of human origins while I was there. And it really increased sort of my skepticism of the standard evolutionary story of human origins. So my role at Discovery Institute is I'm associate director of our Center for Science and Culture. Our Center for Science and Culture is essentially our intelligent design, or ID program, as we call it. And one of my major roles there, or here I should say, as I help to manage our what we call our ID 3.0 research program, where basically we're funding research of scientists both around the United States and also internationally. And we're funding research into intelligent design. I manage a lot of these research projects. I also do a lot of legal work still, helping basically to defend and advise teachers, faculty members, students, parents, educators of different backgrounds to be able to talk about this debate openly in schools or in universities without having to fear for their jobs or getting fired or, getting kicked out of the graduate program or whatever. So I do a lot of the sort of the academic freedom side of things as well. Although my main focus is the science, and that's certainly what I prefer to do is on the science side of things. So yeah, that's a little bit about me and sort of a little bit about Discovery Institute.
When you were growing up, and I guess maybe till 2015 or 2017, 2018, where did you stand on human evolution, and how did that, change or evolve to intelligent design?
Sure. So, well, I think to talk about my journey with intelligent design, we have to go back to my college days, because I worked at Discovery Institute from 2005 onwards. So I've been a proponent of intelligent design for a long time. And it started off for me when I was, as an undergraduate at UC San Diego, I was taking all these courses in evolution, and I wanted to understand evolution. I wanted to learn about it. UC San Diego, I don't know if it still is. I think it probably is. But at the time I was there, it was the #1 public university for biology research in the entire United States. So they have a very, very strong scientific biological focus at UC San Diego. And, I wanted to learn about this topic. And so I was taking courses in evolution. I remember the very first course I took, my first semester of my freshman year, was called History of the Earth and Evolution. And I would get up at this, when you're an undergraduate freshman, like you can't get up before like 10 a.m. because you're up hanging out, talking to friends every night in the dorms. But somehow I had this 8 a.m. class that I'd get up for, run across, just literally running across the quad, almost half in my pajamas still, and get there right as it would start. But in this class, we were learning about how natural selection works and all the complex organisms that have appeared over the history of life. And in that and other courses I was thinking, okay, can you evolve these complex features we see in living organisms in the little step-by-step manner, one little mutation at a time, a manner that is required by Darwin's theory? And I thought, it seems like there's a lot of features that are highly complex, where lots of parts, lots of complexity needs to be present before that part is going to work to give you some advantage to help you to survive and reproduce. And so in my very sort of, no offense to college freshman, I was still, working things out. And, in my sort of rudimentary freshman way of thinking, I was thinking, there seems to be a problem here that the evolutionary mechanism faces, that it can't build things in this step-by-step mechanism that's required by neo-Darwinian evolution, the modern theory of evolution, in order to build these complex features. It's not going to get you there. You have to have all this complexity there all at once, or it's not going to work at all. And so at the end of my freshman year, a buddy of mine, who was also a science major, suggested I read this book called Darwin's Black Box. And I don't know if you've heard of that, Sam, but Darwin's Black Box is a very foundational book in the intelligent design world. It's by a biochemist at Lehigh University named Michael Behe. And in that book, he basically coins this concept of irreducible complexity. And really what he did was he put into words what my rudimentary freshman brain had been thinking that whole year, that he came up with this idea where basically there are many features in biology that are irreducibly complex. If you reduce their complexity at all, then they stop working. And they basically require a core number of parts in order for them to function. These parts, by definition, cannot be built in the gradual, stepwise manner required by the theory, the mechanism of natural selection and random mutation that the modern theory of evolution requires. And so they're a major challenge to Darwin's theory. And in that book, Michael Behe doesn't just talk about, larger organisms. He talks about irreducible complexity at the biochemical level, where we've discovered, and this is for me was really an amazing, eye-opening book to read. I learned a lot about how the cell works reading this book, that the cell is full of what we call micromolecular machines, that there are all these miniature protein robots that are running around our cells performing all kinds of important functions. And many of these machines contain lots of different protein parts, protein components that are all interface compatibility where they can work together to form some function, much like a machine with multiple parts. I'm not saying that the cell is a machine, but I'm saying it contains many smaller structures that are what we would call molecular machines. And this term is used not just by the intelligent design community. You can find many mainstream researchers have compared, these functional components in cells to molecular machines. In fact, Bruce Alberts, who's a former member of the U.S. National Academy of Sciences, he says the entire cell can be viewed as a factory that contains an elaborate network of interlocking assembly lines, each of which is composed of a large set of protein machines. Why do we call the large protein assemblies that underlie cell function protein machines? Precisely because, like machines invented by humans to deal efficiently with the macroscopic world, these protein assemblies contain highly coordinated moving parts. That's a quote from a former president of the U.S. National Academy of Sciences. No friend of intelligent design, but certainly an expert in biochemistry and cell biology and molecular biology. So in this book I read by Michael Behe, he described many of these molecular machines, things like the bacterial flagellum, which is like an outboard motor that allows bacteria to swim around to find food, or other molecular machines like the cilium, which are used in higher organisms, kind of like a whip-like structure. We have cilia all over our bodies to move fluid around, move mucus, to move all kinds of parts within our bodies. And these molecular machines, he argues that they are irreducibly complex, and they pose sort of a fundamental challenge to the Darwinian explanation that we always hear about in our classrooms and in PBS Nova documentaries and all that. So for me, that was my first introduction to intelligent design, and it just all went downhill from there. I started reading other books by ID proponents, started taking more classes, and started just learning about this debate, and just really dove deep into it and got really interested in it.
So for me to understand that's me thinking, if you look at humans, our DNA, our molecules, the way we are designed is almost more complex than what natural selection could have provided.
I certainly agree with that. I think that natural selection requires that every little mutation gives you some advantage in survival and reproduction. You can also have mutations that don't hurt you, okay? I mean, we often have mutations that are called neutral mutations that don't really do anything. But when you're going to build some feature up, you're going to build some complex feature that helps us to survive and reproduce, whether we're talking about, molecular machines in our cells or the eye or, hearing. Every mutation that is making some, change needs to give you some advantage to help you better survive and reproduce, or it's not going to be passed on to the next generation, or at least there's no reason why it should be passed on to the next generation. If it does get passed on, maybe just by chance. But the way Darwin's theory is supposed to work is it wants to say, we can give you a rationale for why these mutations are going to, accumulate to build these complex features, because each successive mutation helps you get better and better at doing something. Okay. And so you build things up one little step at a time. What we see with these irreducibly complex structures is that you have to have all of this complexity present all at once, or the system doesn't work to give you some advantage, some benefit in surviving and reproducing. So you can't build them up one little mutation at a time. So what kind of a cause can basically put together all of these complex components all at once to give you some new feature to help you survive and reproduce? Well, we would argue that the best explanation for the origin of these irreducibly complex structures is a mind, is an intelligent agent, because an intelligent mind can think with forethought and will and intentionality to come up with some complex blueprint that will bring together a bunch of very precise parts to give you some function ready to go all at once as soon as you need it. And that's exactly what we see in biology, these complex features that require many parts to be there all at once, or they don't work. So it's it looks like it requires the kind of forethought and planning that would require a mind to be the cause of its origin.
Gotcha. To certainly understand what you're saying, with the history of intelligent design, where would y'all say it started, or where are some of the first examples you could say?
Well, the debate over our origins goes back thousands of years. It goes back to the ancient Greeks, where you had people like Plato and Aristotle, who actually believed that there was a mind that was behind the universe. And then you had other, ancient philosophers. Democritus is one who was more like an atheist, who believed that, nature could essentially create itself. And so this is not a new debate. It's been carried out throughout, both Western civilization and probably all civilizations in the world. Certainly in the great Islamic civilizations, they developed some of these arguments. One of the strongest arguments, I think, that comes out of modern cosmology is looking at the Big Bang. Mm-hmm. And the Big Bang points to an origin, an abrupt origin to our universe, which points to sort of almost like a creation event. And it was Muslim scholars, also some Christian scholars were involved with this, who developed something called the Kalam cosmological argument, which is an argument that says that anything that begins to exist has a cause. The universe began to exist. Therefore, the universe has a first cause. And modern cosmology has shown that the universe did begin to exist. It's finite in its age and it's finite in its size. You can retrace it back to an infinitely dense and small point where it was created from. So the universe began to exist. That suggests there's a first cause outside the universe that brought it into existence. Very compatible with this idea of intelligent design, or if you want to believe in a sort of an external creator to the universe. So this debate, this issue has been going on for centuries, millennia. Most recently, though, in the last couple hundred years, so Western civilization, when this modern science, this thing that we currently have science, when it got going, the early scientists, people like Isaac Newton or Boyle or Kepler, they all started doing scientific pursuits because they believed in God. They believed in a law-like creator. And they believed that this law-like creator, this lawgiver, would not just create moral laws for us to live our lives by, but would also create natural laws that would govern the universe. And they believed that by studying nature, they could go out and discover the laws that God used when he made the universe. So they were inspired by their belief in a rational, orderly creator and a lawgiver to go out and study nature and seek to find this, the orderly nature of our universe and the laws that govern it. And because of this, they were spectacularly successful in basically inventing the modern methods of science that scientists even use today. Mm-hmm. And it was all started because people believed that there was a creator, a rational, orderly creator behind the universe. And that bore very good fruit. They were able to make all kinds of discoveries under their sort of Judeo-Christian theological, inspiration for going out and doing science. It turned out that it worked. So science was very friendly to belief in a creator, belief in an intelligent mind being behind the universe, until really the 1800s, where there was a shift. And that shift, to be quite frank with you, it was a long process, but it did largely center around Darwin's theory of evolution. So prior to Darwin, most people looked at biology and thought that, again, the complexity of life requires a mind. We see, in living organisms, we see even before, we were able to study the cell under the microscope. People knew that living organisms were highly complex. They could look at the heart that pumps blood through the circulatory system. They could look at the eye and see how it reflects light in order for us to be able to have vision. All kinds of these complex features. People thought, okay, this requires, a mind, an intelligent cause. And so even prior to Darwin, we can see the term intelligent design being used in the scientific literature, okay? But when Darwin comes along, he says, you know what? I've got a different explanation for how the complexity of life diversified and arose. It's called natural selection. And I can explain this without any recourse to a mind or a God or, an intelligent agent. And so when Darwin came up with that idea, it did sort of initiate, it was a major domino that fell in a shift that was going on to change the way science operated and really move science away from seeing, the evidence as pointing to a mind or a creator behind the universe and life. And really that we sort of live in this purposeless, meaningless universe that is strictly material. There's nothing more than matter and energy, and that can explain everything. Just basically matter in motion, and essentially matter comes before mind rather than mind coming before matter. And so Darwin's theory had a major impact, not just on biology, but upon many of the sciences, just that way of thinking, that way of approaching science. And so what we like to say here at Discovery Institute is that, that really was 19th century science, okay? Darwin's theory isn't completely wrong. I mean, natural selection, there's no question, it is a real force that operates in nature. We can see it when we have antibiotic resistance, for example, where, a strain of bacteria doesn't get killed by some antibiotic. Well, it's being selected for, and then it survives and it reproduces, and then, you get an antibiotic resistant strain. Okay, fine. Natural selection is real. But what we would say is that now that we've sort of opened up what we call the black box of the cell and discovered all the complexity of what's really going on under the hood in biology. Michael Behe called his book Darwin's Black Box. We've opened up this black box of the cell. We're now seeing a complex world of miniaturized factories and molecular machines that Darwin could only have dreamed of. Mm-hmm. And it really outstrips the ability of natural selection to explain. So I would say that, the modern theory of intelligent design got a real boost when we started to understand the complexity of the cell, things like DNA, the information in our DNA, things like the molecular machines that we're finding in the cell. And also for modern cosmology, things like discovering that the universe started off with a bang, billions of years ago, where, that bang points to a first cause. Things like what we call the fine tuning of the universe, where we can see that many of the laws and constants of the laws of physics have to be just right in order to yield a universe where life can exist. All this very, very precise fine tuning of the laws of physics, where they have to be exactly the way they are, or you can't have a universe where life can exist. We're making all these discoveries that are pointing to a designer. We would say that intelligent design got a major boost from many of the recent discoveries of, say, the last 10, 20, 50, 80 years in science. But the idea of intelligent design is really nothing new, and has a tradition within science that goes back not just centuries, but actually, I would argue, millennia.
Does Darwin's theory have an explanation of Big Bang and the creation of the universe?
So no, and I wouldn't criticize Darwin's theory for that. I mean, Darwin's theory is supposed to be an explanation for how new species arise. Mm-hmm. All right. I mean, it was called The Origin of Species, right? And he was trying to make a biological explanation for how a new form of life can arise from a pre-existing form of life through natural selection. There's variation within a population. Sure. Some members of that population are better able to survive and reproduce than others. And so they tend to leave more offspring, and the species naturally evolves in their direction. That's natural selection in a nutshell. His theory was never intended to apply to modern cosmology or physics. Now, what we see in modern cosmology and physics is, I would say, similarly materialistic models that are only invoking sort of matter and energy to try to explain away, the evidence for the fine tuning. So we see ideas like the multiverse being brought up in physics and cosmology. I don't know if you're a Marvel fan, but there's been a lot of talk about the multiverse in the last few years. So I mean, Spider-Man, it was a great movie, but it really brought this idea out into the mainstream, right? That there's many different universes. Well, the reason that idea exists is because physicists realized that there is a degree of fine tuning in the laws of nature that's so extraordinary that you would have to envision almost this huge, vast ensemble of universes existing for you to imagine just one single universe getting so lucky, sort of winning that cosmic lottery to get all the parameters just right where life could exist. And we're talking about, numbers like, the precision of some of these fundamental laws and constants that allow for life to exist are, things like 1 in 10 to the 90th power is the degree of precision. That's the precision of the cosmological constant, which controls the expansion of the universe. The value of the gravitational constant. It has to be precise in 1 part in 10 to the 35th power, or you can't get a universe where life can exist. The most impressive one is something called the initial entropy of the early universe. Basically the distribution of matter and energy and how disordered things were. Cosmologists and physicists have determined that in order to get a universe where you can have matter clumping together to form things like stars and galaxies, which of course would be necessary for life to exist, the fine tuning of the early entropy of the universe would need to be fine tuned within one part in 10 raised to the power of 10 to the 123rd power. Okay, so we can't even, you could try to write that number out, start writing that number out, you're going to die long before you even get close. Okay, so the precision of the laws of nature to allow life to exist really is quite extraordinary. And physicists have yet to come up with an explanation for this that invokes sort of materialistic causes. So they like this multiverse idea to try to say, well, if we just sort of imagine that there's this cosmic lottery out there and there's all these other universes with each one has different laws of nature, maybe just by chance, one would get lucky enough to get all these right parameters so life could exist. but there's no evidence for this multiverse. Okay, we only have evidence for one universe, and the mechanisms that they invoke, by the way, to try to explain this multiverse, those mechanisms themselves require even more fine tuning. So you can't really escape the problem of fine tuning no matter what you do. Even the multiverse does not help you escape the problem of fine tuning. We can get into that more, but the bottom line is, the evidence for I think the creation of the universe and the design of the universe is really quite extraordinary. Darwin's theory, I'm not going to critique Darwin. It was not intended to explain that, but even from the physicists and cosmologists who are trying to explain that, I don't think they have a good explanation for it.
Mm-hmm. Well, I do believe, like you said, there's some real world examples of Darwin's theory work that are out there with life, and not just human life. Is intelligent design also in place for animals and the first, dinosaurs, or the first life we've seen in the universe?
Sure. So in the ID, we call it the ID community. We have this motto that says we're going to follow the evidence where it leads. Okay. So ID does not have a problem that perhaps in some cases natural causes are the best explanation. Okay. We're perfectly happy if the explanation goes, in sort of a natural evolutionary mechanism, but we want to make sure we're testing the evidence in each case to ask what is the best explanation. So for the origin of life, I think that most ID theorists would say that you're not going to be able to produce, say, the first cell or the first self-replicating molecule, which is often what they say. That's the first life form. You're not going to be able to do that through sort of just blind chemical reactions. Mm-hmm. And one of the main reasons for that is that life at its fundamental base has information, okay? In our DNA, we have our DNA molecules, basically a long chain of nucleotide bases. There are these base pairs, and they come in 4 different molecules: adenine, cytosine, thymine, and guanine. And these 4 nucleotide bases have to be strung in a very, very specific order to encode all the proteins in your body. Or if you want to talk about, a simple life form like a bacterium, even in a simple bacterium, every single protein in that bacterium is encoded by the order of the nucleotide bases in the DNA. Now, there's no chemical or physical law that says that those bases have to be in any particular order, okay? But yet they are in a very precise order that is just right to allow for these functional proteins to exist. And if you have the wrong ordering of these base pairs, if you get, a mutation, going back to, comic book movies, you get the X-Men or something like that with, in those movies, mutations are always doing something good. But when you look at the literature in the scientific community, usually when we see mutations that are actually doing something, they are invariably damaging to an organism or destroying some function at the biochemical level. So mutations are not very good at building up, getting you the right information you need. Think of writing a computer program, all right? When I did my PhD in geology, I kind of got sucked into the world of Python programming. I ended up writing over 30,000 lines of Python code during my PhD. And what I found is that if you want to put a new function in, you need new lines of code, right? And this was my life for like years. My wife got me a t-shirt that said, "I dream in Python," because it's like all I could think about was Python. It never leaves your head. So in order to generate new lines of code, you don't generate code through randomly typing keys on the keyboard, all right? It just is not going to get you the specificity you need. But yet in our DNA, we see something that is very, very closely analogous, if not almost identical to computer code, where our DNA literally contains commands and codes that are read and interpreted by those machines in your cell to then produce some output. The output would be these protein robots that are going around and performing all the functions in your cells, okay? But it starts off with information in the form of computer-like commands and codes in your DNA. Well, random and unguided blind mechanisms don't produce information that is useful, that is going to be, helping to build a functional protein in the same way that you would never use a random number generator to produce computer code, okay? So we need some cause that can explain how all this information arose in the first forms of life. And we think that, what we're basically seeing in life is a language-based code that is interpreted through computer-like information processing to produce machines. But where in all of our experience do we see language-based codes arising, or computer-like information processing arising, or machine-like structures arising? In all of our experience, those things come only from intelligence. And yet that is what is at the very heart and the very basis of life. And so the origin of life is certainly one key example where we think that an intelligent design would have been necessary to get life going. There's other examples as well. We can get into that. I mean, I think that the origin of animals requires sort of a quantum leap in complexity.
We've been listening to Sam Kleckley talking with the Discovery Institute's Casey Luskin, exploring intelligent design from the ground up. We want to say thanks to Sam Kleckley for permission to republish this conversation from his Live Life in Motion podcast. The rest of their conversation will follow soon after this one, so stay tuned here for the rest. For ID the Future, I'm Tom Gilson. Thank you for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.